Hi, my name is Dan, and this video is one in quite a long series of videos which are charting the progress of using this digital simulating software called Digital Works. It's free, and there's a link to where you can get hold of it in the description down below. And we're using it to build a 4-bit CPU from the basics of logic gates. So it's been quite a long series, and we're getting close to the end. Now, in fact, we've made all our components, and in this video, we're going to start actually putting the components in and start wiring up our CPU. For quite a while earlier on in the big set of videos, things were quite generic. By this stage, they've got very specific to this design for the CPU. All CPUs are different. Other CPUs are available. If you haven't been watching through in sequence with the videos, some of this might not make sense to you. That's okay. Feel free to watch it. It's your choice. There's been a whole lot of design decisions made previously, and if you are following through and you've got to this stage, well done. It's been a long haul, and we've only got a few videos to go before. Hopefully, we're going to have a working, programmable, simulated 4-bit CPU. So let's get into it. In this video, we're going to put in the kind of the basic stuff, which is going to be our buses. We've got 2 of them, and our registers. And our memory. So let's make a start. So we're going to have 2 buses. We'll have one at the left-hand side. What we're actually going to do is going to leave a little bit of a gap so that we can have some extra circuitry on to the left of it, which will allow us to do manual data entry, but that'll be later on. So we're going to start with a 4-bit bus, and we're going to put an LED at the top. And what we're going to do in this circuit is, because this is now the CPU circuit, is that we're actually going to put loads of LEDs all over the place so that when we simulate, we can make sure we know what's going on, or we can see the workings of it. So this is going to be our bus, but I am going to line it up. He says. That's interesting. Why is that one longer than the others? Or I guess the better question is, why is that one shorter? Did I select it by accident? Anyway, that's neater. There we are. We've got our 4-bit bus. Right, so what do we want in here? Let's have some registers. And we'll start labeling them as we put them in. So want 4-bit bus ready registers. We don't want 2-bit, 2 bus registers, so it's just these. And we deliberately put all our bus connections on the left-hand side here, so that they're easy to connect up. Let's be good and label this. We're going to want labels all over the place. Bus 3 to 0. And wire that up. This is going to be the memory address register, MAR. 1, 2, 3, 4. Nearly wired that up wrong there. And the memory address register, the value from that is going to be used in 2 ways. So it's going to be used for our memory banks. So I'm trying to remember the layout that I drew before, but we want 4-bit memory banks. So I'm going to put that one down there, and maybe I should have put the address above. That would have been nice, but I need a little bit of a gap so I can bring those wires around. And we're going to have another one up here, but this other one is the one that's going to hold the ops, the opcodes. So what I'm actually going to do is I'm going to spin this one so that it's upside down, because I'm going to have a second bus, which let's leave some gap there. We're going to have a second bus over here, which is our specific bus for our opcodes. Just going to cut and paste that whole thing to make our second bus. When you do that sort of thing, you need to be quite careful when you're selecting it as a group, that you don't stop it grouping, because otherwise you have problems. Okay, and I'm going to just change that annotation to opbus. Okay, so as indicated, this needs to connect to this. Now, a little tricky, because being upside down, it doesn't attach in the same order as if it were the right way up. Okay, and we're going to want to connect through the addresses here. So this set of values need to go up around there and around this way. Okay, and we need to make sure it goes in the right order as well. So what I'm going to do is I'm going to leave a bit of space. In fact, yes, I've got to be careful because the address is on the. I was pointing up here to the value for the memory bank. In fact, it's the address that I want to connect to. I need to leave some space so we can get some controls in here. I might need to shuffle things around to give us more space. I don't really need everything to be as tight up against each other as they possibly can be. But I've got quite a bit of stuff to get in vertically. And it'd be good to be able to see it all on the screen at once if we can. Variable distances there. In fact, this is kind of now using up all the space that I would have had for the lower memory bank in terms of control. So I'm going to pull that down a bit. Oops, that was just double clicked by accident. So let's pull that down, and we wanted to connect down to here as well. So 3 is that one is already starting to look a little bit messy, which is a shame. That's the next one. I'm not sure if I like that. Never mind. This needs to connect to the bus. Right, so we've got our memory address register. Let's start labeling some of these registers. Which is connected to our 2 memory banks. So this is the it's actually, you can think of it as being the memory data register, but let's just call it mem on this, and the op mem on this memory is the data mem. So mem d. Let's put data in. Right. So next we're going to put in another couple of registers. We're going to put in the actual op register and the data register. So back we go to register 4-bit. And so that is going to be the data register. And that is going to be our op register, which is, so this is also going to connect through to the this data bus for op, and this is going to the general data bus. So let's connect these up. I could have just thrown all these in and then played the music and fast forwarded all this process, but actually I think it's worth making sure we talk through what we're doing as we go along with this, partly because this is the finale, effectively. So that's data. And in fact, we tended to, I know it's a small distinction, but we tended to use all caps for that. And this is op register. And then we're going to need the two registers that work for the ALU. So they're the A and B registers. And we're going to put them down here. We are going to need more space on this bus. Oh, don't double click. Which is slightly a shame because I don't want to be scrolling up and down to see what goes on. So I might want to do some little bits of jiggery and pokery to make sure things are all visible on the screen. I've got quite a bit of space over here that I can use for things. And the reason why this feels like I'm making up the layout as I go along is because I'm making the layout up as I've partly planned it, but it is different to the layout that I used when I did this as a test run. And if you're really interested, let's quickly show you that. So previous, there's my CPU. Only has the tiny template on, the kind of default template, but when we double click inside that, this is the layout that I had. I had the bus across the top and lots of wires everywhere, and it looked a complete mess. And I want it to look better than that. So hopefully it will. It's currently looking more organized, apart from this bit over here. Data, A register and B register. Okay. Now, is that all my registers? No, because I need the program counter. I'm in the wrong set there. Go back to the ones that we've actually created. PC register. So I'm going to extend that down a bit. I'm wondering how to give myself some more space. I don't really have lots of options in terms of giving myself more space, to be honest. What I'm going to do, okay, slightly curiously, is I'm going to put the program counter over the far end. And because the last register to go in here is actually the output from the ALU, which I'm going to pull in here, and then I'm going to bring this right down the bottom and bring it across here. So that's 0. Again, this The slight reshuffle from the expected order is in order to try and get everything on the screen at once. This is only important because when we actually run it and simulate, it's good to be able to see everything that's happening. And we can't zoom out, unfortunately, in digital works or in. It'd be nice to be able to do one of the two. Never mind, we've got what we've got, so we're going to live with it. So I'm going to put the program counter over there. I might even move it further over there. We'll see. Right. Is that all the registers that we're going to need? So now in my head, I know that we've actually got 9 registers in total, but some of them are built into other components. So we've got 3 that are connected with the memory. So we've got MAR and these 2 op memories. Okay. We've got 3 which are to do with the ALU, which is A, B, and ALUX, which we get out. And then we've got 3 which are to do with the running of the program, which is the op register, the data register, and the program counter register. I believe that is all my registers that I'm going to need. So what I'm going to do, obviously this isn't at a stage where we can do testing, but what I am going to do is I'm going to stick on some LEDs so that we can see what's potentially what's going on at various stages. So we've got a set of 4 LEDs here already, so let's cut and paste from here. Copy and paste. I'm going to use that for the seeing what's in the memory address register. Now we're going to want to hardwire out of A and B. Do we hardwire out of data? I don't believe we do. So we can just put it there for the data register. For A, in that case, so I'm asking myself, am I hardwiring into the data for A or B? And I don't think I am. So what I'm going to do is maybe look slightly wrong. Is that this? I'm going to put the A. I'm going to do that. Just ask myself if there's a better way of doing this. And sorry for the hesitation here. What I'm going to do is I'm going to create another set of 4 LEDs that are vertical that I can use to inspect for ones where I'm going to hardwire out. So I'm going to do that for the op set. Now I probably want them to be even closer together. I want to make this take up as little space as possible. So I'm going to make them right up against each other, like that. And I've just done Control-C, Control-V. So I'm going to link those on there. It still looks horrible. And I'm making some design decisions as I go along, which is why I'm kind of hesitant on this. What I'm going to do is I'm actually going to I have thought of another trick that I can use in terms of the bus and connecting everything up to this bus, which is that now I've got these wires connecting to the PC. I can actually connect to the bus on those wires as well. So I'm going to lower the B a bit to just give me a bit more room. I wonder if I can lower those as, oh, not easy to select, that's the problem. There we go. Just to give me a little bit more space there. I am going to put A there, and I'm going to put B below there. Okay. I haven't wired those up yet. That's going to be easier to do when I wire up to the ALU. Okay. Do you want LEDs anywhere else? We've got values sitting on the in the memory, so there's no reason why not to be able to see those values. So one's there, and one's there. Now, that one's slightly tricky because it's upside down, and so the value is wrong way around. So what I'm going to actually do is I'm just going to stretch that up a bit and cross wire it, so that when we look at that, we don't get confused. Hardwire that. And if you hear a slight meowing in the background, that's my cat. Hello, cat. And I think the program counter. So does the program counter hardwire into anything else, or is it just use the bus? I believe it just uses the bus. So again, we can just put the value in there so we can see the value of our program counter. I think that's all my general wiring up that I'm going to do at this stage. I'm feeling a little bit unsure about the fact that register seems to, yes, I'm going to say I've wired those up to data rather than up to value, which is not what we want. So I'm going to delete those, because that's data's the input, not the output. We've already got set through that, so I'm just going to put those down below there. The thing that alerted me to that was the fact that those LEDs were pink, which means not really connected to anything useful. So they're going to light a pink, which means I don't know what this value is going to be, which is fine. And we've got the value out there, value out there, value there. That's going to be connected there. It's kind of a shame that we haven't got LEDs that we can put across there and then pull out from the LEDs again. But the LEDs only work with one connection. We've got our B, we've got our program counter. We might have missed things. We'll see if we're going wrong, but I think that's all, if not most, of the general wiring up that we need to do. So we're going to start getting into the specific components, but I'm breaking this down into several videos. So that's it from me for now.